Welcome back to our review for the Chem 4 final. We're up to our 14th video, Colligative Equations, Part 2. Remember, colligative equations pertain to when you add a solute to water, you get changes in boiling point, freezing point, and osmotic pressure. The changes are based upon the number of particles that ionize. That's why we call them colligative properties. We've covered freezing point, and now we're going to cover boiling point change, which is basically the same formula as freezing point, but instead of K sub F, we have K sub B, and instead of change in freezing temperature, we have change in boiling pressure. So here's our example. If 30 grams of ethylene glycol, an antifreeze, is added to 250 grams of water, and they give you the K sub B as 0.52, what is the new boiling point? Well, let's start with our boiling point formula. The change in boiling point. Remember, in these problems, boiling point always goes up. This is a thermometer. And freezing point is the number you subtract. So this is the number we're going to add to the original boiling point of water, which we all know is 100.0 degrees centigrade. So do we have anything we can plug in? Let's look at ethylene glycol. Remember, the I values are based upon how many particles, positive and negative, release in the water. The only compounds that have an I that's not 1 are the strong acids or bases, the ammonium compounds, the polyatomic ions that have oxygen in them. This is not a strong base or acid. It's not an ammonium compound. It's not an oxyanion. They would probably give you the formula so then you could see that it doesn't have, it's not an oxyanion. So the I in this case is going to be 1 because it's not going to separate into positive and negative ions. So that our next thing we're going to check out is molality. And remember, molality is moles of solute per kilograms of just water. So how do we find moles of ethylene glycol? Remember lifesaver number 1. We have 2 lifesaver equations. The first one is that moles of a compound is equal to the number of grams or mass that you have divided by the molar mass, which they gave us. So our moles of ethylene glycol is simply 30 grams divided by the molar mass, which they gave us, 212.0 grams per mole. So this was easy enough to find. The number of moles is going to be 0.141509439 moles of ethylene glycol. Don't round off in the middle of a problem. I don't care what your teacher does in class. You don't round off until you get to the absolute end of a problem. Now this is still just moles. We need molals. So we need to find the kilograms of water. We have this. Our number of moles is 0.141509439 moles. How do we find kilograms of water? Well, they gave us 250 grams. Don't make a unit error. Nobody likes that. It's grams, so move it 1, 2, 3 places to the left. So we have 0.250 kilograms of just water. And when you divide that, let's see what we get. What did I do? Skip that? Oh, here we go. We get 0.566 molals. That's the hard part. What you just did there is figuring out molals. So now what do we have? Let's come. I'm going to erase all this. Make sure you have it. So our formula becomes delta TB. The change in boiling point, the increase, the amount you add to 100 is I, which is 1. What was M? 0.566 molals. And now we need K sub B, 0.52. That's our solve. So our change in boiling point is going to be 0.29432 degrees centigrade. Let's SUN. Significant figures, units, and number. We have number, we have units. Let's look at significant figures. Go back to the problem, always go back to the problem for significant figures. This has 4 significant figures. This has 3, and if you don't know what I'm talking about, go back and watch the first video. So we only need 3 significant figures. Since this number past the 3rd significant figure is less than and not equal to 5, that means these numbers stay. So our change in boiling point is 0.294 degrees centigrade. Don't make a silly mistake here. You're right there. You're at the brink of greatness. This is the number that you have to add to the original boiling point of the water. So you're going to take, so our new boiling point equals the original boiling point plus the delta TB. So our original boiling point of water, 100 degrees centigrade, plus 0.294 degrees centigrade. So our new boiling point will be 100.294 degrees centigrade. Do we like that value? Let's SUN again. 3 significant figures, 4 significant figures. In actuality, the correct answer would be 100. It's not going to change that much. But make sure you write all the numbers so they see that you know it's going to go up a tiny little bit, even though it's not significant. Okay, so we're going to cut here. I'm going to come back and we'll do our 3rd colligative property, which is osmotic pressure.